Hello and welcome. My name's Ryan. I'm also known as RM2K Dev. Now, in this video, I just want to show you guys some of the server architecture and maybe some of the client-side things that I've changed in the War on Magi project. So first of all, I'll start off with the server. I've pretty much spent the day completely rewriting this. I've moved to a more abstracted model of server architecture. So basically, we set up a standard TCP server here. This is just the main This is just the main TCP server, and basically this just says when an error comes in, log an error. When data comes in, send it to the data function, and when the client disconnects, send it to the disconnect function. And that's pretty much it for the standard TCP side of things. That all gets abstracted to this game class, which is pretty much just a replica of the TCP server. The only difference is, in this class, I handle some game-specific things. So, for instance, when you connect to the game, I send you a list of active games, games awaiting people to join. So, a games list basically to be displayed on the server select screen or whatever screen it ends up becoming. So this is sort of where I can do some game-specific related things that aren't really classified as the standard TCP architecture. It's more of the game architecture. So I've moved that off into a separate JavaScript file, or I suppose class if we were dealing with a C++ or C# project. From here we move into the packet handling functions. So basically I've got a JavaScript file here called packet handler. And this is where I've brought across all of those sort of prototyped functions and maybe refined a little bit of those that I created in yesterday and the day before. So basically, when a packet comes in, so when data comes across through this client data function, it gets sent to the packet handler, which gets told to pass the packet. That goes off into here, which passes the packet. And what this does is it searches for the packet header. When it finds a valid packet header, basically it just it reads the first 12 bytes and figures out how long that packet is, and then basically it takes a copy from the buffer and it sends that to the handle packet function, and then it moves across in the index basically so that you can get all of the packet stuff completed. So moving into the handle packet functions, we basically have this function here. So the first thing that happens is the header of the packet gets decrypted. So that uses packet models. So I've got a function, basically, not a function, sorry, a class over here, which basically defines a couple of packet models. And at the moment I only have two. They are the header and the create game packet on the server. So the header is just an instance of packet header, which defines big endians, skips 12 bytes because they're the first, that's the game maker packet header for the send packet command. And the string we're looking for, basically the first parameter of the header is going to be a string, and it's going to be the command. So that gets decrypted, and then from that we can use the switch, basically select case statement or switch, to switch on the header.command. So that translates into a JSON object which has the value command, and the value comes from the decrypted hexadecimal packet. So sorry, I think that's right, yeah. And basically we switch on that, so we send across from the game the command create game. So if we jump into Game Maker and just have a look at our room, you'll see we have a button on the screen that says create game. When you click that button, I basically ask the user what their username is, what they want to call their room, and if they want to put a password on this game room. And then I execute a script called network create room, which passes across those parameters. If we jump into that script there, network create game, there it is, and that basically just sends across the first packet, which is the command create game, and then those three arguments, which were username, room name, and room password, and that gets sent across to the server. So they get decrypted on the server side. I'm just going to save changes to that. That gets decrypted using this method here on the server side, and basically sets up a game. Each game gets a unique identifier, which is basically just a UUID, so a universally unique identifier. And that gets sent back to the client as a function called setGID. So that stands for game ID. Then we jump back onto the client side, and our networking object will receive the packet setGID, which then basically, I haven't really implemented this is just all testing at the moment, but basically it just stores that, reads it out of the buffer, and shows it in a console.log. Very similar process happens for the game list. So basically when you connect to the server, like I said earlier, the server automatically sends you a list of existing games. Part of that packet is, where is it? it's down the bottom here, game list. It basically is the command game list, the number of games that are in the game list, and then basically the room name, who created it, and then the GID for that room. And then we do the same thing on the game maker side. We decode that. We basically just get how many games there are. So that's going to be the second parameter. So the first parameter was game list. Second parameter is the number of games, and then we just do an iterative loop from 0 to game count and read out those properties: name, created by, and the room GID. And then we create an instance of the join game object on the screen and set those properties, which basically just at the moment are rendering them to the screen. So I'll give you guys a quick demo of what this looks like. So first things first, I'm just going to start up the server. Okay, so the game's running on port 3211. And I'll start up an instance of the game, and I'll show you guys what happens. So at the moment, the game logic is, sort of, I'll put that on the back burner while I set up the server architecture and things like that. But basically, if I hit this create game button, of course, all of this interface and these messages windows that pop up asking for parameters are all temporary. They'll probably replace those with some nice skins and in-game stuff. But what is your name? It's Ryan. What's the name for your game room? I'm going to call this test game. And the password, no password. So what would happen here, and you can see this in the game maker debug window, that has been sent to the server. The server has created a game and a GID, and it sent it back to the client. Now, of course, this is all still just prototyping and still in development. So what would happen next is that the client would store this GID and send the user off to some sort of lobby room while they wait for someone to join their game. So that game's been created. We can just pretend that game is now sitting in existence on the server. The next person who comes along and joins the game connects to the server. And like I said, now you'll see we've got the test game created by Ryan. So what you'll see has happened is I've connected to the server. The server has built a list of games that are currently running. It's assigned them a GID, so you can see the GID, the game ID underneath here. The user who created it was Ryan, and the test game here. So if I create another game, let's change the name this time. It's RM2KDev. Game name, room for your game, John, please join me. There we go. And a password, I'm just going to call it password1234 ASDF. So I'd give that to John over Skype, and he would then basically launch up his game. So I'm going to close that one and launch another one. And he would then see a list of games that are currently available to be played on the server. Obviously, these games don't exist anymore because I've closed the hosting. The hosting game, the person who created that game, I've closed the window, but for the moment I'm just leaving them on the screen in the database, in the RAM database, so that you can still see them on the screen here. But basically now you can see John, please join me, and it was created by RM2KDev, and it also has another universally unique identifier, or a globally unique identifier, or whatever you want to call it. I'm just calling them GIDs in this example. So the next thing that would happen, and it's not done yet, is the user would click on one of these, and basically that would send a join request to the server, which is what I'm currently working on now. And then basically on the server side, with using this architecture that I've sort of come up with today, it would basically have a case statement for join game, which is already here but not completed. And basically it would send across the GID for the game, so you see the GID here. And it would just basically join the new socket into that game. So they would be socket 1 on the join game side of things. Then they would be receiving a packet which would say congratulations for joining the game, or whatever it is, and they would be transported to the lobby as well. And now 2 people are playing a game. The reason I've done it like this is just because it allows me to run one instance of the server and host infinite amounts of games. Well, infinite, as defined by the limitations of TCP protocol. But we can solve that with 3 or 4 different servers, and obviously running multiple instances of these servers on multiple machines hosted in different countries. And we can even go and do load balancing, so that people from certain countries are sent to certain servers and things like that. So this has just sort of been a bit of an overview of the NodeJS server architecture of War of the Magi and the game maker client side. And something I've done, which I think is quite cool, which I'll explain in brief detail. Probably write a blog post on this another day, but basically I've come up with a cool function here called build packet, and this actually translates JavaScript objects. So if they're of type string or of type number, it'll write them into the buffer in the right format. And we also, in the buffer, we're also appending the packet header, which is this string here, but in hexadecimal is this string here. And that's basically GameMaker's proprietary networking protocol. The reason I'm using that is because that allows me to use the networking async load buffer functions. If I wasn't doing that, I would have to I would just be receiving raw TCP into the game basically, and I'd have to interpret all those packets and make sure that there's no packet collisions and see what data comes back, and then append it if it comes back in multiple packets. But GameMaker already has all that stuff built in, so I figured I might as well just decrypt their packet format and sort of build a server that works around that. So that's working quite well. So thank you guys for watching. My name's Ryan. You also know me as RM2K Dev. Please subscribe to my YouTube channel and like this video.